section? Section 1. Okay. Alright, so today we will discuss about the DLC. What is the full form of DLC? Differential leukocyte count. What is the purpose of DLC? Purpose? Yes, to observe or to study various WBCs, various types of WBCs. Very good. Then, so listen very carefully. So WBCs are broadly categorized into two types. What are those? Granulocytes and agranulocytes. Up to here you are okay, but after that you are unable to state the further functions of WBC. Now listen and write down all these points, okay? You should remember for a long time. So what is the difference between granulocytes and agranulocytes? In granulocytes some granules are present and in agranulocytes no granules are present. That is the first case. In granulocytes granules are present. Am I correct? Yes. Now these granulocytes are of three types. What are those?
Neutrophils,
Neutrophils. Okay. Neutrophils.
eosinophils,
Okay. Eosinophils.
basophils.
Eosinophils and basophils. Then agranulocytes we have
Lymphocytes and monocytes.
monocytes and
Lymphocytes.
lymphocytes. Very good. Yes. Now listen very carefully. I just want to add some more fundamental topics, then we will connect everything. So, the theory of staining. I want to say about stains. Okay. What is the difference between a stain and a dye? What is a dye? Can you define? Anything that gives color is called as dye. Am I correct? So, what is a stain? See how you confused? How stain is different from dye. I am not saying about strains. That is different. Strains, like the strains on the clothes. I am not telling about strains. I am saying about staining. Stain. Yeah. How stain is different from dye. Most of you don't know, I guess. Listen. Yes, Srishtika. So, Srishtika trying to say stain is obtained from dyes. Then what? Then we can say dyes, right? Why we are saying them as a stain? Any other idea?
Stain is the process of giving color to something.
So, by saying stain is a process of giving color. Yes? For microscopy. So, Srishtika saying microscopy.
Dye is a thick color, but when we will visualize it at a microscopy light, so that we just see the atmosphere, so that we can distinguish between cells.
So Srishtika tried to say dye is a stain is a dye. Scientifically, it can able to stain the cell or something she is trying to say. Listen, very important property to a stain. Okay. First, I will give you an example. Imagine I have taken a turmeric powder. What is the color of turmeric powder? Yellow. So I took 1 gram of turmeric powder and I dissolved it in a glass full of water. Now this water became a yellow solution. Okay, yellow solution. Now if I use this water on a white kerchief, I submerged white kerchief in a turmeric powder solution. What happens to the kerchief? It will turn into yellow color. White kerchief turned into yellow color when I dipped it in a turmeric powder solution. Right? Now listen. The cloth we understood. Kerchief problem we understood. Now let us assume I have taken 2 drops of turmeric powder solution. I have taken a slide. I kept an amoeba there. An amoeba, a parasite. And I added 2 drops of turmeric powder. What are you expecting? Is the turmeric solution going to give an yellow amoeba?
No.
Is amoeba going to take yellowish color by the turmeric powder solution? It won't. Amoeba not going to turn into a yellow color. Why? Why amoeba didn't took yellow color when a kerchief took yellow color? Because it is a dye. Dyes cannot penetrate into living organisms. Got my point? That means we cannot use a dye to give a color to a cell. We cannot give color to a living cells by the help of dyes. Dyes are not made for that. Now, why dye didn't penetrated into a cell? The problem was dye was hydrophobic in nature, or simply hydrophobic or water insoluble components. Since this is the problem, we cannot colorize a living cell. Now we can make any dye to attach to a living cell. How can I make it? How can I make a dye to attach to a living cell? I can do it, listen. Living cells has a property called surface charge. We have bilipid membranes, right? Phospholipid membranes. Now phospholipid membranes has a charge. Negative charge and positive charge. Now we came to know that a cell wall has a charge. That is the reason why I am giving you one best example. This plastic material don't have a charge. So I cannot use my mobile. But my finger has a charge because my blood was flowing in the capillaries and they are constantly creating a negative charge on my skin. So this negative charge will be detected by the sensor in the mobile, leading to a feather touch, they are saying, right? So this is the same property. We understood that a cell has a charge. Now let us do one thing. If I give a charge to my dye, if I give some either positive charge or negative charge to my dye, now this became a charged dye. A charged dye can able to attach to a cell. That charged dye is called as stain. Simple. A dye with a charge, it can be positive charge or negative charge, is called as a stain. And stain will be used for colorizing cells. Colorizing cells. Now you understood, right? What is a stain? A stain is a dye that has a charge which has the capability of colorizing a cells. Cells can be two types. Now listen. Now I am going to tell about various types of stains. I am giving you a classification of stains. A very simple classification, not much, not depth. Classification of stains. If we want a stain that will colorize a living cell without killing the cell. I have an amoeba, I stained the amoeba. Upon taking color, amoeba should not die, it should be alive. Because I want to study the motility of amoeba. I want to study its movement. That means I don't want to kill the amoeba. So I need a stain that will able to sustain the life of the cells. Such stains are called as, do you know what is the meaning, what is the other word for life? Living, vital signs. So these stains are called as vital stains. One example of vital stain, I want to study cancer in a tumor. Okay, I took a biopsy and I want to study only cancer cells. Both cancer and normal cell look same, but I added a dye I added a vital stain that will only bind to the living cancer cells. So there are some special scenarios where we want to use a vital stains to study the living cells. They are called as vital stains. Clear, right? Then second one, special stains. What are these special stains? Special stains will specialized stains that will only bind to some specialized categories. I will give one example. There is a bacilli. That bacilli requires, bacilli has a very strong hydrophobic cell membrane. Very strong hydrophobic. That means even normal stains cannot penetrate into this bacilli. Very strong cell wall. Due to this nature, I need to destroy the cell wall first with the help of phenols. Then I will use a very strong acids to penetrate my dye into the cell wall. And this bacteria is called as acid-fast bacilli. And acid-fast bacilli, can you guess what is the bacteria? Tuberculosis. Mycobacterium tuberculosis. So, to stain a tuberculosis, we need a special stain where it can able to penetrate a very large cell wall. And that stain is called as Ziehl-Neelsen stain. Ziehl-Neelsen stain, Nelson stain, Zn stain. So, Zn stain is one of a special stain. So, now we understood what are special stains. Am I correct? Any more doubts so far? Yes. Next one. Next one is very interesting. I will keep only 3. Romanowski stains. What is the meaning of Romanowski stains? Romanowski stains. Romanowski stains. Romanowski stains. Yes, Melissa. Melissa, right?
Yes, sir.
Yes. What is your doubt?
Sir, I think there are stains that can stain the nucleus and the cytoplasm in different
Oh,
colors.
you want to define Romanowski stains? Listen. I appreciate you, but I will let you know what exactly the Romanowski stains means. Whatever dye that is mixed in an alcohol, any dye that is mixed in an alcohol, these dyes are called as Romanowski stains. Any dye that is mixed in an alcohol solution, any dye that is mixed in alcohol solution, those stains are called as Romanowski stains. Clear? Now listen. Almost 99% of hematological stains, the stains we are using in the hematology lab are Romanowski stains. Okay? Stains we are using in hematology are Romanowski stains. I will give few examples of Romanowski stains. Yes. 1. Leishman stain. Leishman stain. 2. Wright stain. Wright's stain. W-R-I-T-H-T. Wright stain. 3. Pearl's stain. P-A-R-L-S. Pearl's stain. I need it actually. Pearl's stain. Okay, Pearl's stain. Then methylene blue. Methylene blue stain. Methylene blue stain. Ginsa stain. Ginsa alone. Okay, Ginsa stain. Okay. These are few Romanowski stains. By the way, if you want, I will let you know one more classification. If a stain has more than 2 colors, if a stain has more than 2, not differential, that is different story. Now you are making me complicated. Anyway, let me tell you. If a stain has more than 1 dye, that is called as compound stains. If a stain has only 1 color dye, that is called as simple stains. Simple, 1 color, compound, more than 1 color are called as compound stains. Okay. Then we have differential stains that we will discuss later. Differential stains means these stains will color various cells in various colors based on the cell property. They are called as differential stains. One example of differential stain will be Pharmacology. Okay. Pap stain. Yeah, Pap stain, PAS stain, panionic acid shift stain. These are few examples of differential. Anyway. Example of vital stain. Vital stain example, OG6, Congo red. Congo red is a special stain used for amyloid deposit staining. You are saying negative stain and positive staining. Now you are again going with classification. Let us keep this concept aside because stains classification is really very big topic. Okay. Positive and negative. We got a point here. Positive stain means any stain that will only stain the cell are called as positive stains. Now there are some instances where we cannot stain a cell. Maybe it is an oil block. Oils cannot be stained. In that scenario, we won't stain the cell, rather than we will stain the background. We will colorize the background and we will see the cell over a black background, dark background. Such stains are called as negative stains. Negative stains will stain the background of the cell, not the actual cells. Keep these things aside. Clear? Now you know what are stains. See, it's a new world, all stains. So initially you thought dye and stains are same. Now you tell me what is the difference between a dye and stain? A dye is a colorized component without charge, whereas a stain is a dye with charge that has the capability to colorize a living cells, living or dead cells, is called as a stain. Clear?
Yes.
Now I will tell the principle of any stain. Principle of any stains. Okay? Principle of stain. Now write down principle of stain. Now let us assume Leishman stain principle. Leishman stain principle. Or any stain. I am giving one example, Leishman stain. Listen, in this Leishman stain, first I will write here a cell. So cell has two components. Broadly cell has two components, a nucleus and a cytoplasm. Very good. What is the pH of nucleus? pH of nucleus. What is the pH of nucleus? Yes, tell me the pH of nucleus. This Ria was really confused nowadays. What is the pH of nucleus? Why are you confused? Let me tell you the pH of nucleus. Inside the nucleus, what we have? DNA, right? What is the full form of DNA? Deoxyribonucleic acid. So nucleus is always acidic in nature. Simple. The full form of DNA is an acid, and DNA always present in nucleus. So nucleus is always an acidic in nature. Now tell me the pH of acidic. Less than 7 is acidic. Nucleus is acidic in nature. Is it clear? Can you able to remember till you were there? I mean lifetime. That is negative word. Sorry. Then cytoplasm. What will be the pH of cytoplasm now?
More than 7.
Acidic?
No.
Basic. Vice versa, right? Basic in nature. Okay. Overall pH will be basic, but there might be some granules that might be acidic or basic that we'll see later. Clear?
Yes.
So now you know the pH greater than 7. Basic in nature, cytoplasm, and nucleus is always acidic in nature. This concept is clear.
Yes.
Now let us see the stain. Every stain will have two things. Every stain will have two things, an acidic part and a basic part. Every stain will have two things, an acidic part and a basic part. Either acidic or a basic, or we can write both or any one. Both or any one. Clear? Let us assume acidic part. Okay? So there is a dye in acidic part that is called as eosin. Eosin is a pink color component that is acidic dye. Okay? Now you tell me logically, an acid will always react with base. Am I correct? So this dye will bind to what part of the cell? Cytoplasm, because cytoplasm is basic in nature. So eosin is a cytoplasmic stain, or we can say eosin is an acidic dye that binds with the basic part of the cell, that is the cytoplasm. See, the concept is very simple, but it looks like complicated. If you understand the concept, this is really interesting. Clear? Eosin is an acidic dye that binds to the basic part of the cell, that is cytoplasm. Clear? The next one, basic dye. Here the basic dye is methylene blue. Methylene blue. Methylene blue is a basic dye that binds to the acidic part of the cell. Acidic part of the cell. Hence this dye is called as nuclear stain. Nuclear stain. And this is cytoplasmic stain. From today onwards, no matter whatever the stain is, all the stains has these two properties. That's it. You should know what is the basic dye in that stain and what is the acidic dye in that stain. Now these dyes will come in different names. Eosin, methylene blue, ginsa, carbalfuscin. There are multiple names for these dyes. That's it. That is the concept of stains. Is it clear?
Yes, sir.
That is the principle of stains. A basic dye will bind with the acidic part of the cell, and the acidic dye will bind with the basic part of the cell. So acidic stains are always cytoplasmic stains, and basic stains are always nuclear stains. Clear?
Yes.
Any more doubts in this concept? No, right? So by this I already given you an example of Leishman stain. In Leishman stain, what is the basic dye? The basic dye in Leishman stain is methylene blue. What is the color of methylene blue? Blue. And what is the acidic stain? Eosin. pH of acidic eosin? pH less than 7 means acidic, and it binds with the basic, that means cytoplasm. Right? Clear. Very good. Then I said a property of Romanowski stain. What is the property of Romanowski stains? Characteristic feature of Romanowski stains, what is it? Yeah, they are always present in a alcoholic solution. In our Leishman stain, alcohol base is, write down, it is this. Somewhere I wrote. Yeah, acetone-free methyl alcohol. Acetone-free methyl alcohol. Acetone-free methyl alcohol. Acetone-free methyl alcohol is the solution. Now listen. Now there is a problem with alcohols. Once we add a dye to an alcohol, it will start bleaching it. Of course, alcohol will give charge to the dyes, leading to a stain. But alcohols has a bad property called bleaching. What is bleaching means? Slowly the color will fade away. Slowly the color will fade away. That is why always these stains will come in a box like this. They will give a solution. See, this is a clear solution. Can you guess what is this solution?
Alcohol.
Alcohol. What type of alcohol? Methyl alcohol. Acetone-free methyl alcohol they give it to us. Okay. Now to this alcohol, they also given us a small pouchet. A small pouchet has been given. What is it? So in this there is a color, dye, powder. What it might have? It will have methylene blue. Methylene blue and eosin powder present in this sachet. Okay. Now we will add this sachet into this alcohol solution, leading to a stain. A dye became a stain. Now the stock life, the shelf life of this solution, once adding the dye, is 9 months. Within 9 months we should utilize it. Why? Because this alcohol will start bleaching the dye and it takes around 9 months. So within 9 months we must utilize the stock reagent or the shelf reagent. Clear? So ideally what they said was, after adding it, every 24 hours we need to shake the bottle for even mixing of the dye. So today we might not get results, but we'll give it a try. And we already have previous stains, we'll see. Clear? So now you understood the stains. Now I just want to tell you one of the preliminary stain we used for hematological disease, hematology. That is a H&D stain, hematoxylin and eosin stain. Okay, eosin is pink. Okay, hematoxylin. Basic. Now, coming back to my classification of white blood cells. Say for this classification, I given this fundamentals by the way. Yeah. Now listen. I think everything clear so far. So we started this lecture with DLC. So what is DLC? Differential leukocyte count. Different types of white blood cell count. Simply, we are differentiating 5 types of white blood cells. Clear? So now we say, what we did was, the scientist observed a cell. In this cell, write down the cell structure, everyone, very important. Morphology of each white blood cells. Neutrophil. Okay, write down. Please write down these points, okay. So first of all, we already know the percentage of each cells, right? What is the mnemonic for this? Never let monkey eat banana. What are the percentages? 60%, 40, 20, 8. No, not 20, sorry. 1 to 8, then 8 to 4 to 8, then 0 to 1. Am I correct? This is the percentage of various white blood cells, neutrophils, lymphocytes, everything. Yeah, sorry. 6 to 8, correct. 6 to 8 and 4 to 1 to 4. Oh, okay. Yes, 1 to 4, correct. 4%, 1 to 4%. Clear? Yeah. Now listen. 1 to 4%, correct. Now, what are the most abundant cells? Neutrophils. What are the least populated cells? Basophils. Clear? Now, let us assume my patient got an acute infection. Whatever infection, it can be a bacterial infection, viral infection, parasitic infection or fungal infection. Immediately, once a patient get an infection, an acute infection, what cells will increase? Initially, neutrophils. Whatever the infection, neutrophils will drastically increase. Neutrophils are the first line of defense cells. Right? Let us assume my patient got specifically a parasitic infection. If a parasitic infection, what cells will increase? Eosinophils. That means these are anti-parasitic cells. My patient also developed an asthma. He is sneezing a lot and he has a chest, breathing issues. That asthma or allergy is also mediated by eosinophils. Okay. So anti-parasitic and allergic cells are eosinophils. Clear? I'm giving you the functions of each cells, by the way. Next one. Anti-cancer cells. If there are any cancers, and cancer, basophils will act as an anti-cancer cells. Anti-cancer cells. Also, basophils will secrete one important natural anticoagulant, heparin. Heparin was secreted by basophils. These are the functions of basophils. Clear? Yes. Now, if my patient got a viral infection, a heavy viral load infection, don't expect basophils shoot more than 1%. Never. Even if the patient has a virus infection, maybe COVID, still the basophils won't go above 1%. Okay. Basophils has a threshold. If basophils are more than 1%, that indicates a very, very deadliest condition in the patient. It might be even blood cancer. Only in severe conditions, basophil rise more than 1. Okay. So usually, in viral load, if the patient has viral infection, usually the lymphocytes will increase. Lymphocytes will secrete, one of the lymphocytes is B lymphocytes. B lymphocytes will secrete antibodies. Okay. So antibodies are secreted by lymphocytes, plus when there is a viral load, the lymphocyte count will increase. Okay. Lymphocytes are of two types, small lymphocytes and large lymphocytes. I don't want to go there. Small lymphocytes are T cells and large lymphocytes are B cells. There are further divisions. I don't want to touch it. Clear? Yeah. Then in some specific infections like malaria, tuberculosis, typhoid, malaria, TB, typhoid, monocytes will show a moderate increased levels. Monocytes will show moderately increased levels in some conditions like malaria, TB, and typhoid. Clear? Yeah. Now, write down some terms also. Now you know the functions of each white blood cell. Am I correct? Functions of each white blood cell you understood, and you know the percentage of each white blood cells. Thank you, Melissa. Then now write down the conditions. The conditions means, let us assume increased neutrophils is called as, any idea? Increased neutrophils is called as what? Neutrophilia. Write down. Neutrophilia. Increased neutrophils is called as neutrophilia. I guess today we can't do the practical. Anyway, first let us finish reading. Increased neutrophils is called as neutrophilia. Decreased neutrophils is called as
Neutropenia.
neutropenia. Very good. Penia means reduced count. Neutropenia, decreased neutrophil count. Increased neutrophil is called as neutrophilia. Very good. Next one. Increased lymphocytes is called as lymphophilia. Yeah. Yeah, write down. Lymphocytosis. 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 Increased lymphocytes is called as lymphocytosis. Decreased lymphocytes is called as lymphocytopenia. Very good, Manpreet. Lymphocytopenia. Decreased lymphocytes is called as lymphocytopenia. Now, based on this, tell me increased monocytes is called as monocytosis. Very good. Monocytosis. Decreased monocytes is called as monocytopenia. Very good. Monocytopenia. Clear? Yeah. Next one. Increased eosinophils is called as Eosinophilia. Very good. Eosinophilia. Decreased eosinophils is called as eosinopenia. Okay. So usually basophils won't increase. If that is the case, basophilia and basopenia. Okay? Usually the terms are not there because decreased basophils is a good condition. Ideally we should have less basophils. Clear?
Yes, sir.
Yeah. So now you know the conditions of increased, decreased, functions of white blood cells, percentage of white blood cells. Clear?
Yes, sir. Yes.
Last and final, morphology of white blood cells. Morphology of white blood cells. Morphology of white blood cells. Let me keep this here. Yeah. Morphology of white blood cells. Listen here. What are the three granulocytes? Neutrophils, eosinophils and basophils. Then agranulocytes, monocytes and lymphocytes. Clear? Now listen. The naming of these cells has been derived by staining actually. When scientists started staining the white blood cells, they started naming the cells. What they did was, initially they saw some granules, so they are granulocytes and no agranulocytes, no granules. Okay. Next one, in neutrophil, they found both in the cytoplasm. They found both acidic and basic granules. Acidic and basic granules. That means both pink color granules and blue color granules has been identified. Since it has both acid and basic part, these cells are named as neutral charge, leading to neutrophils. It's just a name, doesn't mean the charge. Okay. Neutrophils doesn't mean they have neutral charge. Still they have a charge. That's why the strains has taken them. Okay. So yeah. So in the cytoplasm, they has both pink and blue granules, both acidic and pink will be basic granules and blue will be acidic granules. From the point of view of cell or stain. Got my point? Understood? I said basic granules. Basic granules will take acidic dye and acidic granules will take basic dye. So yeah, so that's it. Then coming to the nucleus of neutrophil. Nucleus is very important to identify the type of cell. In case of our neutrophil, the nucleus was multi-lobed. Nucleus has multi-lobes like this. It has multiple foldings. Okay? Neutrophil has multiple lobes. Multi-lobed nucleus is present. And also they say, imagine this is a day 1 cell, day 5 cell, day 10. This is the age of the cell. The greater the age of the cell, the more the foldings of the nucleus. 2 folds, 3 folds, 6 folds. That means the more the folds, the elder the cell. Clear? Understood, right? So the folding of the nucleus, the lobes of the nucleus will determine the age of the cell. Since this nucleus was changing day by day, they also named it as polymorph cell. Neutrophil is also called as polymorph cell. Poly, many, morphology cell. Why it is called many morphologies? Because it is changing its nucleus lobes depending on its age. That's why neutrophil is also called as polymorph cell. So these are the properties, morphology, of neutrophil. Clear? Multi-lobed nucleus, both acidic and basic granules are present in the neutrophil. Clear? First line of defense cell, common and most evident cell. Next one, eosinophil. In this eosinophil, the granules are always taking eosin dye. Since the granules taking eosin dye, they named the cell as eosinophil. Eosinophil. Now we understood why eosinophil is called as eosinophil. Because they are taking eosin dye. Clear? And what is the color of eosin?
Pink.
Pink. So the granule colors are always pink. Okay. Then coming to the nucleus. What is the shape of the eosinophil nucleus? It is bilobe. Bilobe nucleus or spectacle shaped nucleus. Spectacle shaped nucleus or bilobe nucleus present in the eosinophil.
Basic granules.
Huh?
Basic granules.
Basic granules, correct. But acidic type eosinophils. Okay. So don't overthink at the level of principles during study of cells. Okay, you will get confused because now I am coming to basophils. Okay. Now listen. Now basophil, it will take the basic dye. Okay. What is the basic dye? The blue color, methylene blue, right? That is why they are taking basic dye, that is methylene blue. Hence, these cells are called as basophils. Basophils, because they are taking basic dye, that is our methylene blue. Hence, these cells are called as basophils. And what is the shape of the nucleus? The shape of the nucleus looks like sigmoid shape. An S-like sigmoid shape the nucleus can be seen. Now there is a problem with the sigmoid shaped nucleus. This sigmoid shaped nucleus also looks like a bilobe once the cells are reoriented. Sometimes basophils nucleus looks like a bilobe. Sometimes basophils have a bilobed nucleus. Then how you will differentiate, distinguish a eosinophil from basophil? By the color of the granules rather than depending on the shape of the nucleus. Because sometimes nucleus looks both bilobe. Then go to the granules. Blue color granules present to the basophil, whereas pink color granules present to the eosinophils. Clear? Very good. Then coming to the monocyte. In monocyte, no granules are present. A single nucleus is present, that's why mono. Okay? And the nucleus looks like a kidney shape. Kidney or bean shape. Kidney or bean shaped nucleus present to the monocyte. Clear? That is the shape of the nucleus of monocyte. Right? Last and final, lymphocyte. Lymphocyte has a large crescent moon nucleus. Okay? Only this is the portion of the cytoplasm. Almost the entire cytoplasm was occupied by the nucleus. Okay? So, yeah, this is the lymphocyte. Simple. Clear? These are the various types of white blood cells, their morphologies and their principal, Leishman stain, properties. Clear? Yeah. Now, let us understand the procedure of Leishman staining. Procedure has only 5 steps. Write down the procedure of Leishman staining. First of all, you will make a smear. Obviously, you will make a blood smear. Am I correct? What is the shape of the smear? thumb-shaped smear. You made a smear, right? After making a smear, you should do the following things. First, you will add 2 to 3 drops of Leishman stain. 2 to 3 drops of Leishman stain. First step, 2 to 3 drops Leishman stain. Or they are saying like this, the stain should entirely cover the slide. The slide should be covered with the stain. Okay? Then, you need to wait for 2 minutes. Wait for 2 minutes. This is the second step. Wait for 2 minutes. Clear? Then, third step. We should add a buffered saline. If we don't have a buffered saline, we can use a distilled water. Add 8 to 10 drops, or entire slide should be covered with the distilled water. Entire slide should be covered with the distilled water. Then you need to wait, fourth step, wait for almost 8 to 10 minutes. Adding stain, wait for 2 minutes. Add distilled water, wait for 10 minutes. Clear? After 10 minutes, what you will do? Fifth step. Under running tap water, okay, slow streamed running tap water. Don't keep in a high flow, very gentle, slow streaming running tap water. Under running tap water, you need to wash the slide for next 2 minutes. Wash the slide under running tap water for 2 minutes. Okay. Then what you will do next? After that, air dry the smear. Then what you will do? You will start observing on the microscope. First, you will observe on the 40x. In the 40x, you need to identify the body. Okay. Listen. If this is the tongue shape, head, body, tail, you should start observing near body and tail region. Near body and tail region, observe where there is the boundary of red blood cells to white blood cells. Until one boundary, you will see Rolls formation of red blood cells. At one particular point, you will see white blood cells. Eventually, the field will change. Okay. Once you identified your white blood cell field, white blood cells, now you will add a drop of cedarwood oil, and you will add a cover slip, and you will observe on the 100x. You will start counting white blood cells. How to count the white blood cells? Now listen, very important. You will draw a box. You need not to count all the 11,000 cells. Just count 100 cells, that's it. Listen. You draw a 10 into 10 box. 10 this side, 10 this side. How many total? 100 boxes. Okay. Now under the microscope, you count the cells. The first field. Listen. This is the smear, and you will start counting like this. This is tick jar. The field you need to rotate like this. Okay. This is first field. Count. Maybe you counted 10 neutrophils. Then write neutro N. Then you identify 2 lymphocytes. Right, L. Then you changed your field. Next field. In this field, how many neutrophils? Maybe 6 neutrophils. You will fill the boxes. You need to fill the boxes until you are filling 100 boxes. That's it. After 100 boxes, you will count how many neutrophils, how many basophils. That's it. You will get your count. That is differential leukocyte count. Simple. Clear? So now already made a sample report for DLC. See, I already given a box to you. You need not to plot the box. Directly you will write NM, neutrophil, lymphocyte, monocyte, that's it. Now I want to tell you one interesting thing. My senior, I think I shared this story with you. I shared this story. It is my BSc first year final practicals, and we have a protocol that first practicals will be conducted, then theory exam. If you failed in that subject practical, you are not allowed to the theory exam. So theory and practical are connected. If you fail in practical, you need not to write the theory exam. Because why we are writing theory exam? To make the practicals, and you don't know the practical and how you will write theory. That is the logic in government hospitals. So very strict. So what my classmate did, he nicely kept a DLCs here. Doctor came and he started saying, I am observing basophil. Doctor asked again, what are you observing? He said it's basophil. And he checked his report. Nicely he kept BBB everywhere. Nicely he wrote basophil in almost all the boxes. And that is a normal blood sample. Friend's sample. Is it possible to have so many basophils? So what doctor did, he kept his paper backlog. He failed in the practical and he also not allowed to the theory exam. And he didn't clear his paper when till the time I was in my second year of my masters. He cleared his first year physiology subject in my master's second year. It took 5 years for him to clear the paper. Actually, back papers are very tough in medical college. Yeah. Supply particular, they will torture a lot. Yeah. So what I was trying to say was, be serious in this one, because your reports will determine the patient status. Now you might ask me a question, sir, why we are doing all these painful things when we have machines like this? This machine will give DLC report in 60 seconds, and this machine will count all 5 types of white blood cells. Okay? That is why this machine is called as Hematology 5-part 60 seconds reports H560. This is a 5-part fully automated machine. Clear? Now, if we have a machine that will give report in 60 seconds, why we are doing manual test? Can you guess why? Let us assume this machine gave 10 basophil report. What you will do? Will you dispatch the report? If this machine given 10 basophils in a patient sample, are you going to dispatch that report? Are you going to trust this machine? We should cross-conform manually by doing manual counting. At the end of the day, when a severely deviated reports came, we must do manual counting. We cannot rely on any machines. Even if it is a 10 crore machine, we don't rely on them. At the end of the day, they are brainless machines. So a physical manual observation is always important. And never think that even in future, the future students will shift to complete automatic. Never happens. Always manual methods are gold standard, because manual methods are supervised by a human with actual brain. Right? Yes, we can trust it from an automation. That is the idea why we will always teach manual methods in the labs. Clear? Yeah, this is the story of DLC. Any doubts in DLC now? So what is the, now listen, the most commonly used stain is not Leishman, it is bright stain actually. See, we have bright stain here. Bright stain is the best stain for DLC. Okay, yeah. If you don't have bright, then you can go for Leishman stain. Clear? Then, what is the percentage of monocytes? Percentage of monocytes? 6 to 8. Yes, Miss Chantal. How to count? Simple. You got one field of microscope. There you can clearly see neutrophils, basophils, everything are visible. So in your field, how many neutrophils are present? If you see 7 neutrophils in your field, you will write 7 times N in the boxes. Then you saw 3 lymphocytes. You will understand once you are checking in microscope. Easy. Okay. Yes. Any more doubts in this test, by the way? Yes, Shantanu? You are still having some confusion. What is the most commonly used stain, by the way? Right stain. Then Leishman stain. Okay. What is the principle behind staining? Acidic part will bind to the basic part and basic dye will bind to the acidic part of the cell. So yeah. That's it, students. Get ready for the quiz and we'll do practical.